Welcome to YQ Academy, SQL, Interview Questions and Answers. 1. What are the steps you will take if you are tasked with securing an SQL server? 1. Secure physical access. Ensure that the server is located in a physically secure environment, such as a locked server room or data center. Limit access to authorized personnel only. 2. Enable authentication. Implement strong authentication mechanisms for accessing the SQL server. Use secure passwords or consider using more robust authentication methods like Windows authentication or Active Directory integration. 3. Implement role-based access control. Define user roles and assign appropriate permissions based on the principle of least privilege. Only grant necessary privileges to each user or role to limit access to sensitive data and functionalities. 4. Encrypt sensitive data. Implement data encryption mechanisms to protect sensitive data at rest and in transit. Consider using transparent data encryption (TD) for encrypting database files and secure socket layer (SSL) or transport layer security (TLS) for securing data transmission. 5. Keep software up to date. Regularly apply patches, updates, and security hotfixes provided by the database vendor to address known security vulnerabilities. Stay current with the latest releases and security advisories. 6. Implement firewall and network security. Use firewalls to restrict network access to the SQL server. Configure appropriate network security groups and access control lists (ACLs) to allow only necessary traffic to reach the server. Consider implementing intrusion detection and prevention systems (IDPs) for additional protection. 7. Secure backups. Protect database backups by encrypting them and storing them in secure location. Implement proper access controls and authentication mechanisms for backup files. 8. Monitor and audit. Set up monitoring and auditing mechanisms to track and log activities on the SQL server. Monitor for suspicious or unauthorized access attempts, unusual data modifications, or abnormal resource usage. Regularly review audit logs for security incidents and anomalies. 9. Implement security best practices. Follow industry best practices for SQL Server security, such as disabling unnecessary services and features, using strong passwords, implementing two-factor authentication, and regularly reviewing user accounts and privileges. 10. Regular security assessments. Conduct regular security assessments, vulnerability scans, and penetration testing to identify potential security weaknesses and address them proactively. 2. What is a deadlock and what is a live lock? 1. Deadlock. A deadlock occurs when two or more processes or threads are blocked indefinitely, each waiting for the other to release a resource that it holds. In other words, it's a situation where two or more processes are stuck and unable to proceed because each process is holding a resource that another process needs, while also waiting for a resource that is held by another process. As a result, the processes are in a circular dependency, and none of them can progress. Deadlocks can lead to system instability and a complete halt of the affected processes. 2. Livelock. A livelock is a situation where two or more processes or threads are actively running, but they are unable to make progress because they keep responding to each other's actions without making any real progress. It's like a busy loop scenario where processes are constantly reacting to each other's actions, but the overall system remains stuck in a non-productive state. In a livelock, the processes are not blocked or waiting for resources like in a deadlock, but they are stuck in a repetitive, unproductive interaction. 3. How will you go about resolving deadlocks? 1. Detect the deadlock. Monitor the system and identify the occurrence of a deadlock. This can be done by analyzing system logs, error messages, or using specialized tools or techniques for deadlock detection. 2. Gather information. Collect information about the processes involved in the deadlock, the resources they are holding, and the sequence of events that led to the deadlock. This includes gathering information about the transactions, locks, and resources involved. 3. Identify the deadlock participants. Determine the processes or transactions that are part of the deadlock and the specific resources they are waiting for. This information will help in understanding the root cause of the deadlock. 4. Analyze the deadlock graph. Use the deadlock graph or information gathered from the system to analyze the dependency chain or circular weight that is causing the deadlock. Identify the resources that are involved in the deadlock and the order in which they are being acquired. 5. Choose a resolution strategy. Based on the analysis, select an appropriate strategy to resolve the deadlock. Some common strategies include deadlock detection and resolution. Use deadlock detection algorithms or built-in mechanisms provided by the database or operating system to automatically detect and resolve deadlocks. This may involve killing or rolling back one or more processes to break the deadlock. Resource preemption. Determine which process or transaction can tolerate rollback or interruption and forcibly release resources held by that process to break the deadlock. This requires careful consideration of the impact of resource preemption on the overall system and the affected processes. Resource allocation ordering. Establish a consistent order for acquiring resources to prevent circular weight and ensure that processes always request resources in the same order. This helps in preventing future deadlocks from occurring. Timeouts and retries. Implement timeouts or wait limits for resource acquisition. If a process exceeds the timeout period, it releases its held resources and retries the operation, avoiding long waits and potential deadlocks. 6. Implement the chosen strategy. Apply the chosen strategy to resolve the deadlock. This may involve releasing resources, rolling back transactions, adjusting resource allocation, or modifying application logic to prevent future deadlocks. 7. Test and monitor. After implementing the resolution strategy, test the system to ensure that the deadlock is resolved and the affected processes can continue execution. Monitor the system closely to identify any recurring or new deadlock scenarios and take preventive measures. 4. What is blocking and how would you troubleshoot it? Blocking occurs when one transaction or process holds a lock on a resource, preventing other transactions or processes from accessing or modifying that resource. This can lead to delays and performance issues. Troubleshooting blocking involves identifying the blocking processes and taking appropriate actions to resolve the issue. Here's a step-by-step approach to troubleshooting blocking. 1. Identify blocking. Monitor the system and identify any processes or transactions that are being blocked or are causing blocks. This can be done through system logs, database monitoring tools, or by querying system views or tables that provide information about current locks and blocking sessions. 2. Analyze blocking chains. Identify the sequence of blocking processes and transactions. Determine which processes are blocking others and which processes are being blocked. This helps in understanding the root cause of the blocking issue. 3. Understand the resource contention. Identify the specific resources tables, rows, or other database objects that are being accessed or modified by the blocking and blocked processes. Determine the type of locks being held on those resources. 4. Investigate the reasons for blocking. Determine why the blocking is occurring. It can be due to long-running transactions, conflicting lock modes, lock escalation, query performance, or application design issues. Analyze the queries, transactions, and application logic involved in the blocking. 5. Resolve the blocking. Based on the analysis, take appropriate actions to resolve the blocking. Some common strategies include kill or rollback blocking processes. If the blocking processes are not critical or can be rolled back without adverse effects, consider terminating or rolling back those processes to release the locks and allow other processes to proceed. Optimize queries and transactions. Analyze and optimize the queries and transactions involved in the blocking. This may involve adding or modifying indexes, rewriting queries, or restructuring transactions to reduce contention and improve performance. Adjust locking and isolation levels. Evaluate the locking and isolation levels used by the processes. Adjust them if necessary to strike a balance between concurrency and data consistency, considering the specific requirements of the application. Implement timeouts and retries. If appropriate, introduce timeouts or retries in the application logic to handle scenarios where processes are waiting for resources. This prevents indefinite blocking and allows processes to proceed after a certain period. Review system and database configuration. Check the system and database configuration settings, such as maximum concurrent connections, memory allocation, and parallelism settings. Ensure that they are appropriately configured to handle the workload and prevent excessive blocking. 6. Test and monitor. After implementing the resolution steps, test the system to ensure that the blocking is resolved and the affected processes can proceed. Monitor the system closely to identify any recurring or new blocking scenarios and take preventive measures. 7. Optimize and tune. Continuously optimize and tune the database and application to minimize blocking scenarios. This includes ongoing performance monitoring, query optimization, index maintenance, and periodic review of application design and concurrency control mechanisms. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.